All right, let's get started. Hello and welcome to the first in what we hope will be a long series of HEBI Robotics webinars. My name's Colleen. I will be moderating the presentation today, which is titled Introduction to the HEBI Platform. Please take note that today's webinar will be recorded and the recording will be sent out to everyone who attended as well as those who registered but couldn't make it. As we go through the presentation, all attendees will be automatically muted, but please feel free to send us questions using both the question and chat functions in the GoToWebinar menu bar on the side. We'll do our best to answer them as they come in, but we have dedicated time at the end of the webinar for some question and answer time. Now, we would like to start this webinar off with a quick teaser demo, so I'm going to hand it off to our engineers, Andrew and Hardik.
So as Colleen just mentioned, we're going to kick things off tonight with a small teaser for later in this presentation. As you can see, I'm at home and the other arm you're seeing is in the office. I'm going to control my arm here so that the arm in the office says hi to all our attendees here today. We like to call this, as you'll see in a second. So as you can see, the arm I'm moving is causing the arm in the office to control. You can see Andrew saying hi over there. And as you might understand the joke, this is us giving you a sine wave. But this is just a quick teaser, so we'll talk more about how this demo was made possible, as well as play with some other demos at the end of this presentation. Right now, right after this demo, we're going to get started with a short 4-minute video introducing HEBI and our founders.
My name is Howie Chosit. One of my motivations for participating in the start of HEBI Robotics was to keep the band together.
And in 2014, we started the company.
I was introduced to HEBI as I was pursuing my MBA at Carnegie Mellon's Tepper School of Business. I became employee #1 after the founders.
We're known as the Snake Lab because the thing we're most known for is making snake robots. And in the process of making these robots, what we wound up doing is making modules.
It was those modules, those actuators, which we can put together almost as if you're playing with Lego.
Really lets robotics experts move much more quickly and do things in the real world that they weren't able to do before.
That's really what HEBI Robotics is about. We want to accelerate the development of robotics by endowing developers with the ability to put robots together in a relatively short time and not have to worry about all that low-level crap that you have to deal with when putting robots together for the first time.
That's where our hearts are. We're saying, how can we speed up research across the board?
And go back to the field more quickly.
It's a robotic actuator, enables you to build new and different types of robotic mechanisms. You kind of have an idea of what you want to build, so you need these parts that will speed up your process.
And just like Legos, it's a kit that you can start with, and then you can take apart and you can change, you can modify, you can make more exciting in different ways. Either pre-assembled or with instructions for how you can put together a fully working robot. Here's code to give you a starting point.
It says, okay, what are people going to do with this? If we enable them, if we provide the tools, what will they think of?
All the developer has to do is focus on the creative innovation.
We also provide custom development.
We can very quickly, using ideas from modularity, go in and build customized robots in small quantities of 10, quantities of 50. HEBI Robotics is going to have a future in making a large variety of customized robots, perhaps as quickly as people who mass-produce systems today.
What we have today is a system that makes it possible for the roboticist, the robotics expert, to create world-class professional-grade robots quickly.
We would love it if we could enable someone that does not have a PhD in robotics, that's not coming from academia, to actually build and program a robot.
We want to make working with hardware as easy as working with simulation.
so that the robot builder can focus on the more creative, fun aspects of building a robot.
It's the people who made these robots great. Robots aren't great. Robots are just tools. And my hope is that we at HEBI Robotics stay together for as long as possible.
All right, so now I'm going to hand it off to our presenters. First up, we have Andrew Willig, who is a mechanical engineer here at HEBI. Willig, take it away.
Great, thanks. Can you guys all hear me?
You're all set.
Great, awesome. Hi, thanks and welcome everyone. My name is Andrew Willig. I am a mechanical engineer here at HEBI Robotics. I work mainly on the mechanical design of everything from individual components to full robotic systems. Joining me today, as you guys saw, is Hardik Singh. He is a junior product manager. He focuses on connecting the dots between our customers' needs and our software development. You guys heard a lot in that video we just played about why HEBI was started and a little bit about our founders. To give you a little bit more background, our main office is located in Pittsburgh, Pennsylvania. We also have an office in Salzburg, Austria to help support our European customers. Like the video discussed, our expertise includes robotics hardware and software with a core focus on motion control, which is mainly just how things move, how robotic systems move, really just trying to simplify that. So what can you expect from this webinar today? Firstly, we are going to go through kind of the HEBI Robotics approach. What are we trying to accomplish with this HEBI Robotics platform that you're going to learn about today? Next, we'll show you how customers today have already applied our technology successfully in their own work. And then we'll do a deeper dive into the platform itself, talk about the hardware and software overviews. You saw some of that in the demo and in the video. And then also talk about the tools that we have to help guide you along the way in using all of that hardware and software. And then lastly is the fun part, right? The demos that we just did a teaser of. We'll do low-level demos, show you how to get up and running with individual parts, and then also at a kit level, how we have all this example code to get you up and running. And then also as you saw, well, we'll play a fun little game of remote tic-tac-toe between me and Hardik. So that's what you can expect to gain from this webinar. What do we want you to learn and take away from this webinar? Well, first, what the HEBI platform does. Why is it so great and so versatile? How can your industry or research benefit from using it? So maybe you have a project in mind already that you can apply our platform to. And lastly, if you're a current customer, are you utilizing all the different services that HEBI Robotics provides? Are you making the most out of your experience? And then lastly, I'd like to remind everyone to please use the chat box in the questions to ask us questions here, me and Hardik. And then we'll get to those. If we don't answer them when we get into the meat of the presentation, we can answer those live too. So in today's world, building robots is very difficult. It combines a variety of hardware and software engineering disciplines where your options are either to build robots from scratch, where you have to fully customize from the ground up, and this is very costly and time consuming, or the other option is to purchase standardized hardware where you're buying something pre-made that typically lacks the versatility your application calls for. So you're really buying a one and done solution, and once it's finished completing a task or that project is completed and it's served its life, it's just going to sit on a shelf. What we here at HEBI Robotics have created is an agile platform for robotic development in order to, what we like to say, accelerate the future of robotics. By building we want to make building robotic systems simple, useful, and safe. We want to make both robotic experts and novices able to design, build, and actuate tailored solutions for any application your imagination can think of. We want to keep this process cyclical too, so that when you're done with this specific project or that specific solution, you're not putting that robot then on that shelf. You can now reconfigure it or reuse it for another application. So in order to have a successful solution, you need reliable technology. HEBI's platform utilizes modular reconfigurable hardware. That's not just one thing, as I just stated. You can recreate. There's embedded sensors, so you can do a variety of different control and feedback from that technology. It's also mechanically compliant, and we'll talk about that later. We also utilize the idea of plug and play technology, so it's standard power and Ethernet, so it gets you up and running very quickly and very easy to daisy chain. And then lastly, we have very powerful software APIs and tools, and all that does all that annoying robot math behind the scenes, things like kinematics and trajectories. On top of the reliable technology, we do everything we can to cater to you, the customer, so that you can get the most out of our hard work. This includes simulation tools so that you can try before you buy, as we like to say, so that you can run all of your software development beforehand, before you actually have physical hardware. But then when you get that physical hardware, you can run that exact same code that you ran in simulation on the physical hardware. You can also get up and running very quickly by buying individual piece parts and then put them together into your own design. Or we also sell pre-configured kits with loaded example code that I'll dive into later in the presentation. But we also do custom development. We work with customers to create new technologies, leveraging the concepts built into our hardware and software. And then lastly, something we're experimenting with is kind of like a Netflix style subscription plan, kind of like the old school Netflix, where you get access to a couple different DVDs. This helps, as I'll explain later, when you're having trouble picking which HEBI components you want and you're not exactly sure. This gives kind of the subscriber access to some quantity of hardware, and then you can swap out components depending on as your project evolves or as your needs are more clarified. And with that, I'm going to pass off control to Hardik, and he's going to show you how some customers are already using our technology in successful ways. Hardik, control is now yours.
Thanks, Willig, for giving us that flavor of what HEBI Robotics is all about. I'm going to start by walking us through some of the ways in which our customers are using the power of the HEBI Robotics platform, as this is a good way to understand what's possible with our tools. On the right, in the next slide, you can see a handful of our customers from around the world, which span both the academic and industrial spaces. And we specialize in helping them do in days what could otherwise take months with traditional hardware. We take care of all those low-level aspects of robotics, as Willig mentioned. Putting together the electronics, mechanical hardware, and software, yeah, we've already taken care of that for you. Over the next few slides, I will show you some of the ways in which our customers have used the HEBI platform to develop all types of robotic solutions. In particular, I will be highlighting how HEBI's Agile Robot Development Platform has allowed us to move faster, more easily. First up, we have a research group at Facebook. This is an example of a customer who used a HEBI robot as a jumping pad towards sophisticated AI and machine learning research into robot locomotion. What's important to note here is that they started with a stock pre-designed HEBI kit, which is known as our HEBI hexapod, or DAISY, which is a nice name that we've given to it. They wanted DAISY because they needed a stable platform that had the ability to walk, but they wanted to investigate and research what the best way to make that walking happen was. They did not need to design a new robot from the ground up. And so our kit provided exactly that starting point that they needed, so that they didn't have to design it from the ground up to do that groundbreaking research. And so this is one way in which our stock kits are a great starting point for many of our users. Next up, we have another research group at Google DeepMind who was tackling some similar issues, but had some key differences in how they did that. They were also tackling reinforcement learning research for legged robots. And for them, they were actually attracted to the low-level control access of the HEBI platform. And what this means is that they wanted to be able to customize a little bit more of the robot. As you can see on the bottom, using the same hardware, they were able to create all different types of robots. And that goes with what we mentioned and what we talk about as like the Lego aspect of our platform. They have different types of 4, 5, 6, 3, and 2-legged robots, all from the same hardware. And another thing to note here is that they were able to first create these robots in simulation, test them in simulation, and then even create that exact same robot from simulation in the real world. And so this was an example of a customer who took our tools, took our stock hexapod kit, and adapted it to their needs. And that customization is key as a part of the platform that we provide. Finally, we have a slightly different example here, which is that our same tools are, with the same power of modularity and configurability, become accessible learning tools for the next generation of roboticists. We were able to introduce sophisticated robotics in a classroom setting with our tools. As this video plays on the right, you will see a robot that can toss a table tennis ball with accuracy. It can play Connect 4, and you'll see this in a second. It can flip. In this case, you can see the famous bottle flip challenge that became famous over the internet. The really cool thing here is that these robots were all built by students who were being introduced to robotics for the first time. And in doing so, after having been given this hardware, they had a certain freedom for what they could build. And this allowed them to learn the basics of robotic systems, including things like computer vision, machine learning, and motion control. These are all aspects of robotics that you can integrate into our platform very easily. And in this way, for the students, they were able to get hands-on experience designing systems with real robotics hardware and software. But from our side, what we really like to emphasize is the fact that students who are using robots for the first time were able to create real functioning applications in just 5 to 6 weeks. And this hardware is being used at academic institutions in the US and also in Europe. So it's really powerful what you can do with our tools because they are easy to use, both for the robotic expert, but also for someone who can just be brand new to robotics. Beyond providing simply powerful robotic tools to our users, HEBI Robotics also has the in-house expertise and infrastructure to quickly expand our catalog with that same hardware and software so that it can better suit a customer's needs. What that means is that we can utilize our own platform to create custom develop robotic solutions that address the customer's unique applications. We can also provide consulting services where we work with industry partners to advise on and further develop systems that efficiently and safely integrate robotics. For the same platform, we have the qualifications and experience to take a solution from the prototype to a scalable production level. And this includes with using our own in-house production team. The summary of this is that we are the experts at using our own tools for development. And at a glance, this means that we can get everything done all under one roof so that you spend less time creating a system from the ground up. Let's look at 2 quick examples of how exactly our custom development can speed up your robotic solution and implement it faster. We have a group at Ericsson that approached us with a specific need. You see the 2 robots with their arrow between them. The one on the left was what we provided at the time. It was a X series robot. We'll talk later about what X and R series are, but it was an X series robot. It was a mechanism base that they saw and they said, this is close to what we need, but it's not exactly what we need. So after they were able to approach us with certain specifications, we were able to create the robot on the right. That is also the robot you see moving around that had additional sensor payload, that had the additional rigidity and structure that they wanted, and it also used our R-series modules, which are waterproof and dustproof. So what we're going to show here is that they were able to continue with their work by providing us the additional specifications that they wanted. And with this new platform, it took us less than a month to fully design and manufacture this new base for them. So we can act quickly, we can go with your specifications that you want, and it makes it possible to also integrate LiDARs, cameras, other sensors, which is what our custom development can make possible for you. So this is an example of where something that we have was close to what you need, and we can adapt it to what you really need. This next example takes that even further. We are able to also create systems that have real world impact and also expand our hardware and software solutions that we have available today. So in this case, we worked with subject matter experts at Chevron and certain other groups to create a uniquely tailored solution for industrial inspection. On the right pictured is a passive universal encoder arm for inspection tasks. It's called MAPS, the Modular Absolute Positioning System, and it's a lightweight portable passive arm that just measures the position and orientation of a probe. It's used to collect encoded inspection data for complex geometries, and this was something that was able to speed up the rate at which some industrial inspection could be done by orders of magnitude. And the coolest part here is that we stand to make a big difference in an industry after just getting to a working prototype in 3 months. Idea to working prototype was quick, and we can iterate quickly, we can prototype quickly, and we can get a system on the ground quickly. I don't want to talk too much more about this solution, this application in particular, because today's focus is going to be all about the agile robot development platform that we have. Next week, however, we have another webinar called MAPS, HEBI's new NDT technology. It's on Tuesday from 2 to 3 p.m. Eastern time, and it will be presented by our co-founder, Dave Rawlinson. Please come and join us for that webinar if you are interested in learning more about this industrial application in particular. But putting all of those customer stories together, what we really have is that with HEBI Robotics, I want you guys to leave here today knowing that you can dream as big as you want. Whether it is by starting with our base actuators and modules on the left, or whether it's by getting rolling with a stock kit like that shown in the middle, or whether it's by creating your own novel solution to a robotic challenge on the right, we've got you covered. Just to kind of highlight some of the examples we have on the right, the images on the right show, the first image shows a 7 degree of freedom arm that is using chopsticks. The next one shows a robotic backpack that helps you support heavy objects, and you can wear that, and it was built with our technology. Finally, the last image is a tensegrity structure ball that can roll by itself. These are robotic applications that were made possible with the platform that we've created to be modular, to be configurable, and to bring into reality the kind of solutions that we need to bring robotic automation hopefully into the commonplace. We really make it as easy as possible to build anything from a traditional robotic arm, as fast as a 6-legged heavy hexapod, like a spider type robot, or just anything else you can imagine. But enough now that we know what can be done with our platform, I think it's time to take a look at what the platform is, itself. And for this, I will pass it back to Willig.
Thanks, Hardik. To get started, I'm going to play another short video, but I will narrate over it. So let me get that started. So here's an introduction to an X series actuator here. Like I said earlier, these are very easy to get up and running. So here you see it's standard Ethernet and power to plug in. There's lots of sensing built into this, so you can do simultaneous control of position, velocity, and torque, and even more. You get feedback, and you can even send commands back and forth. And then beyond that, there's built-in IMUs to every actuator, so you understand the orientation and where gravity is. So you get accelerometers and gyros. It's also on the network, so you can use other sensors on the network, like IMUs in your phone. So you'll see here, as he takes out his phone and rotates his phone around, we're reading in the velocity from the IMU on the phone and forwarding that feedback and sending commands to the actuator. The APIs have built-in tools, so you can handle dynamics and smooth out the commands to send trajectories. So those commands are now trajectories and smoothed out. The actuators are also series elastic. As I said, they're mechanically compliant. So you can also do force sensing, but you can also command a force. So as this arm spins around and he interacts with it, they're almost like shock absorbers. So he's not hurting the actuator and the actuator's not hurting him. So he's able to interact with it. And then finally, as this video comes to a conclusion, there's a nice big reveal that the whole thing will shut on a 6 degree of freedom arm built out of the actuators. Ta-da! All right. So now I will come back to the presentation. and show my face. Great. All right. So here are the X series and R series smart robotic actuators that we've been alluding to. They are continuous output motors, basically. They require no calibration or homing on boot up. They also contain a through bore, so it's easy to wire up and easily daisy chain. This actually allows these actuators to be used anything from wheels to multi-degree of freedom collaborative robotic arms to anything you can really put your mind to. The X series you see on the left are great for the researcher doing work in the lab or in an indoor environment, whereas our newer R series actuators are a little bit more ruggedized. They have an IP67 watertight rating, so that's really great for those more challenging field applications. These actuators are also built on the idea of modularity, which is kind of the key aspect of our platform. You keep hearing the words reconfigurable. You'll also hear the word modularity a lot. So this allows you to tailor your system really, really specifically to what you want to do and what your application calls for. Within each of these power classes you see on this kind of data sheet, there's a trade-off you have to make between torque and speed, which is naturally what comes along with gearing and mechanical design. If you want further information about these actuators, there's handouts you'll find in the GoToWebinar meeting. But to further talk about the reconfigurableness, I'll just give some quick examples. For example, if you want to use an X59 actuator, which is the highest torque actuator in the X5 power class, this is a great actuator that we use all the time for our gripper spools on our robotic arms, because you get a lot of torque out of it to grasp objects, but you also limit the amount of additional weight that you're adding onto the arm, since it is kind of the lighter of the weights in between the X5 and the X8s. Whereas in X8-3, you kind of jump up into the next X8 power class. These are great for wheels because you have a great high power, but you also get that high speed, and you don't necessarily need as much torque. This is great, and we use these in our mobile base kits, and we even use these as the wheels for our self-balancing robot Igor, as shown in the image below. And then finally, something like an R816, which gives you the same specs as the high torque but low speed X816, has the additional benefit of that IP67 rating to be used outside for that industrial inspection, military, agriculture, or other dirty environments. Really kind of gives you that additional torque to be used in a shoulder joint, for example, here in an arm. An additional side note, in this image, you can actually pair up actuators in a single joint and use them in parallel to give your robotic joints more torque and more payload capabilities. In addition to the actuators, we offer all of the accessories that you would need to build and configure your robot. We want to make building these robots as easy as building with Lego. We provide an assortment of accessories such as brackets with generic mating features that make connecting actuators quick and simple. There's even hollow tubes with indexing holes that mate with these brackets, and it helps keep wiring clean, and it also ties into the software and the kinematics. We provide different lengths of wiring and cable lengths to make the daisy chaining nice and clean and easy. And then there's even these cable actuated grippers you see in the top right that really helps keep the weight at the end effector low by keeping the additional actuator that's adding that actuation for the gripper back towards the base of the arm. As you saw in the Caltech video, our hardware and software also allows you to create your own custom mechanical parts or connecty bits. So you don't have to use these accessories, but this is kind of all built into our APIs, and you can use either or, whatever suits your application. In addition to the individual components, we provide pre-designed and assembled robotic systems that we like to call kits. These can be configured to custom specs and also come with preloaded code that help you get up and running right out of the box. The arms are the most common example. We've dedicated an entire set of tools that I'll demo in a second. But there's also these other kits that we've shown, like the hexapod, mobile manipulators, and mobile bases. But going back to the arms, we've dedicated an entire set of tools. There's a dedicated API for arms that we'll demo at the end. But I'm also going to show off our robot builder website here right now. So I'm going to step out of the presentation and demo the robot builder, and we can take a second or two for some questions.
Feel free to use the question tab over in the GoToWebinar sidebar if you have anything, while Willig gets this all loaded up. The question we got earlier that I wanted to let all of you all know about is you are allowed to share the webinar recording with anyone who hasn't registered to attend. You're more than welcome to do that.
Okay, can you guys all see my new screen?
Yep, that looks great.
Cool. So this is our robotic arm kits page on the website. You can easily get here by going to the website, HEBIRobotics.com or HEBI.us, and you go to hardware and then robotic arms. What you can do is you can scroll down and pick any arm that you want. For this purpose of this demo, I'm going to select a 5 degree of freedom X series arm. So that would load up. And then what you can do here is you can see all the different specs for a 5 degree of freedom arm with or without a gripper. And at the bottom of this page, all the documentation for how to build one, the data sheet, HRDFs that we'll talk about a little bit later. But then also there's this button to configure your own. So what that link would bring you to, and I've pre-loaded it here, is our HEBI robot builder. So what you can do here is you can start from scratch, or you can upload your own HRDF to create your own robotic arm. So I'll show this real quick. I have an X89, an X89, another X89, an X51, and an X51. And then if I go over to this test drive tab, you can see this continuous payload right now in its current configuration is about 1/4 kilogram, peak payload 2.5. But what I can do, and I can move this around slowly, see what the kinematics kind of look like, and see how that payload changes. But if I'm looking at this and I'm like, I could probably use a little bit more payload, you can go back into the build, come back to the shoulder, replace that shoulder joint, and come over to the sidebar, replace it with an X816, and just readjust. What I can do now and see that the payload has increased significantly, and I can drive it around. So that's one way to reconfigure your robot by just the configuration of the actuators themselves. So switching from an X89 to an X816. Additionally, what you can do is you can change these links. So I could change the link too. So if I want that further link to be a little bit shorter, maybe I want the twist to be a little bit differently to change kind of the kinematics of how the arm moves, I can do that. And then I can go back to this test drive and drive it around, and you can see how the payload and the kinematics has changed. And then finally, when you've found your final configuration and you want to get a quote for this setup or in this configuration, you can come over to the request a quote tab here, and you can email us and it will send us exactly that configuration that you want, and we can send you a quote back as to how much that costs, with or without us assembling it for you, and get you going from there. We have any questions, or should I keep going?
Somebody asked about documentation for implementing code as they're a beginner, but we will actually kind of get to that later. Do you want to take that, Willig?
Yeah, we have a wealth of documentation, and we're going to get to that in probably 5 minutes or less. Hardik's going to talk about that in just a little bit. All right, so I'll continue on. So lastly, on the hardware side, we have this piece of hardware called the HEBI I/O board, which is something we created to act as the bridge between our APIs and low-level third-party sensors. It's an Ethernet-enabled device, so it's easy to network and daisy chain along with the actuators within your system. It provides analog digital inputs, digital and PWM outputs, encoder inputs, and more. There's even an IMU on board as well, so you can get orientation estimate readings from this as well as the actuators. And you can see here, there's a list of various different applications or example uses for this I/O board, one being controlling pneumatic valves. So if you didn't want to use our cable actuated gripper, you could set up something like a vacuum gripper on an arm and control the pneumatic valves with this. I do want to note, however, this is not a motor controller for the actuators. The actuators themselves have all of the control electronics built into them. So you do not need this I/O board to control the motors, the actuators themselves. Additionally, you will need some kind of computer, an Intel NUC that we use in our kits, something like a Raspberry Pi to control your system. This is also not a replacement for that. And with that, to talk about the software, I will pass control back over to Hardik. Hardik, control is yours.
Awesome, thanks, Willig. Now that you've had a chance to look at a lot of our hardware tools and what makes up the platform on the hardware side, I'll take this opportunity to show you how that comes together with the software. On the slide, what we can take a look at is that we have a breadth of accessibility to our tools. So we have, depending on your experience with robotics, you are able to use anywhere from anywhere on the spectrum of tools, the kind of things that we offer. So to get into them a little bit more, at the very high level, we have some abstracted tools, such as our ARM API, which in this case, as we'll see later today, the ARM API, it makes it really easy to interact with an arm. So if you were to give it a space, a coordinate in 3D space, the arm would be able to take the end effector there. Simple functions like that, which would otherwise require you to know a lot of complicated robotics math and kinematics on the back end, that's all covered for you. So with things like the ARM API, the trajectory generator, which has similar functions of making motion control very smooth, and the robot builder that you already saw, we make it easier for those who are less familiar with robotics to be able to use our tools. On the other end of the spectrum, however, we also have low-level access to the commands and feedback at an actuator level. So to each individual actuator, you are able to send commands and receive feedback. And if you really wanted to, you can even go all the way down to the raw PWM of the motor and get commands and feedbacks on that front. But whether you are wanting to use an abstracted tool or you want to get into the low-level nitty-gritties, you can do either of those, but you can also operate anywhere in the middle. And so between these two sides of the spectrum, we have tools that help you with trajectories, with kinematics, with control, making it easier and harder and smoother to control the arm. You are able to log everything about the arm, everything from internal kind of winding temperatures and their models for that, to even simple things like position, velocity, and acceleration. You also have simulation tools, integrations with other hardware, with the I/O board. There's really, as I'll get into a little bit of the details about the software in a second, but I want you to know that you can feel comfortable operating wherever you are comfortable, and we make that possible. So on the next slide, I'm going to talk about how we have a variety of APIs. We have 4 APIs actually that in particular you will want to be looking at. So you can really use the environment that you are most comfortable with and best suits your project. We have MATLAB, ROS, Python, and C or C++ in particular. For most of these APIs, you can comfortably use them on the operating system that you most commonly use. So Windows, Linux, and OS X are supported throughout everything, with the exception of ROS, where we definitely recommend using Linux, as if that has the best support for ROS. And the other cool thing is here is let's say you are new to ROS, but you're comfortable in Python or C or C++. We've made it possible so that you can use Python and C++ inside the ROS environment and focus on, again, where you are most comfortable. So you can really choose where you want to work with our APIs. In terms of some of the supplemental applications that we have some tools that we know will solve some of the problems that will come up during development. So you want to be able to know, if you want to be able to know what's happening with the ARM internally, we have Scope. Scope is our multi-purpose monitoring and configuring utility that allows you to do everything from logging to setting control gains and renaming hardware on the network, finding hardware on the network. There's a plethora of things that this can do that allows you to make the most of your development time. Scope becomes an indispensable tool for understanding and tuning your system when you use it in parallel with your APIs. So if you have your API and your code open, you should also have Scope open to really see how what you're sending as commands are affecting the robot by creating plots and seeing, tracking the change of data over time. It can be used and brought in for troubleshooting, even if it's used on another computer. So the cool thing that's there is that if you have a computer running a robot, you don't need to be running Scope on that same computer. You could come in with your other laptop, with your other computer, and still connect to the same network and track all your hardware there. So there's a lot of cool things that you can do with Scope that we highly recommend you keep in mind. Next up, another tool that really helps with speeding up development is our HEBI mobile I/O app. It is available on Android's Google Play Store, as well as the iOS App Store. And it's an app that you can download for free and allows you to provide input to your robot. So we came across things like where people using different joysticks or keyboards had different issues because you may not have a particular model of a keyboard. You might have to use additional threading for your keyboard. You may not have the model of a joystick. There's just a lot of issues when it comes, there can be a lot of issues when it comes to providing input for your robot. With the HEBI mobile I/O app, it simplifies matters. You can quite easily set control to the different buttons, sliders, and joysticks on your mobile I/O app. And it's just a matter of taking the phone out of your pocket, connecting it to the same network as your robot, and you can get going. So we've made it easy to provide input in that way. Continuing with some of the different tools that we have that make it easy to control your robot, we have some cross-platform software tools that simplify the otherwise difficult task of sophisticated motion control. So first up, we have the HEBI robot description format. This is an XML style format that stores robot configurations, including kinematic and dynamic information. So the useful part about HRDF is that it's API agnostic, but also robot agnostic. What does that mean? The API agnostic part means that if you have a robot on hand and you have described it, as you can see here, you can describe where the actuators are, you can just describe what length of links you have, what the, just really the kinematic details for your robot. You can switch from MATLAB to Python to C++ to ROS very easily because the same HRDF file will describe your robot to all of those APIs. So if you're developing with a friend, they like MATLAB, you like Python, you could just pass the same HRDF between those two computers, between the two users, and it would still work. Switching over the robot agnostic part of the thing, it makes it easier for your code to be changed. So if you've created code for a 6 degree of freedom arm, but you want it to switch over to a 5 degree of freedom arm, to pass that kinematic information to your code, you just need to change 2 lines in your HRDF. So again, it makes it very easy in terms of passing that relevant information into your code. You don't need to change or recompile everything. Similarly, I want to take a moment to highlight our simulation tools. We have support right now in ROS and through ROS Gazebo, but also in the standalone Gazebo form. And we have some more simulation tools on the way that we've heard from users that could be really useful for them. Similar to the HRDF, you don't need to change the API you're comfortable with when you're using our simulation tools. Once you have the simulation up, you can choose Python, MATLAB, C++, ROS, whatever you're comfortable with. And that, again, makes it very easy to operate in your comfort zone. And that's the part which is API agnostic. The other thing about our code is that oftentimes when you have a simulation that's running for a robot, you might need to write your code specific for that simulation. The cool thing with our simulation tools is that the same code that runs on your robot in the physical world will also run on the simulation world and vice versa. So you can technically prepare and test out code in the simulation world where the robot won't have to interact with anything or be set up, and then you can just easily bring it over to the real world and implement it. The other things I'll mention here is that both these tools are actually free for you to look at right now, and I'll talk about that in a moment with our documentation, but you can find our HRDFs online on our GitHub, and the simulation tools are also on our GitHub ready for you to download and use. So if you have any doubts about whether the robot is the right choice for you, you can download these tools right now, give them a try in simulation, and talk to us. We'll help you figure that out. At this moment, I want to take this slide to really emphasize something that will be as useful to our potential customers as it is to our current users. There are 4 best friends in development, and depending on how long you've been using the HEBI hardware, you may not know about these latest tools, or you may. So let's take a dive. Your first best friend is going to be the example code that we have up. We have made an effort to make sure that all 4 of our APIs have the same example code that helps highlight our features and simultaneously shows you how to implement them. So we had a question earlier in the webinar as well about where this example code can be found, and this is on our GitHub. So it's on our GitHub page, github.com/HEBI Robotics, and that GitHub page can also be referenced from our documentation page, which again, I'll talk about in a moment. The example code is a really useful starting point, and we highly recommend that you get started here because it allows you to really get familiar with the hardware and operate at a point which we know works for you. Your next best friend is scope. As I mentioned earlier, it can really be an invaluable tool when it comes to development, and especially when used in tandem with our APIs or example code, we highly recommend you always have scope open and use it as your best friend whenever you need to figure out what's going on. Next, and this is something that we really want to emphasize to our users, it's something that gets undervalued quite often, but it's logging. When you contact us for support and you say, hey, something about my robot is not going exactly how I want it to go, most commonly the first question we'll ask you is, can you send us a log file of what's happening? The reason for this is that the log files record everything about the robot, and it makes it very easy to see what's going wrong, if there is anything going wrong, and also allows us to more easily make recommendations to you during your development and makes it easier for us to consult with speeding up the development and making sure we figure out everything for your needs. So just if I was to put a big star on this slide, remember log files. Always be tracking log files. To make log files, you can do so in our code, but this screenshot, for example, is from Scope. So inside Scope, there is the inbuilt functionality to create log files as well, and open log files as well. And finally, we have the HEBI community. There's a wealth of documentation and resources and people that make up that HEBI community. And so that's why I want to talk about the HEBI community as a whole in this next section. Hope you guys are all with me right now because we've had a chance to go through the platform, and now we'll see how the people and the resources that we have around that platform make it more usable for you as a user. There is a wealth of documentation. We said this a few times, but we really want to emphasize it. We encourage you to take full advantage of all that the platform has to offer. One thing that we believe sets HEBI apart is our documentation and our understanding of how critical it is. There are lots of awesome software tools out there and hardware tools out there in this world that nobody knows how to use because they're not properly documented. And so we want to make sure that we're on the right side of that balance. Most importantly, we have docs.hebi.us. This is the home base for our documentation, where you'll find everything from quick start guides to core concept information, mechanical and software walkthroughs, documentation, as well as downloads for our latest tools and our APIs. Docs.hebi.us is the page you open to understand how to do more with the HEBI platform. Similar to docs.hebi.us, we have cad.hebi.us. As you can see, we've done a little bit of effort to make sure the URLs are easy for you to remember and to find. Here at cad.hebi.us, you can find CAD files and drawings in case you want to build or 3D print or manufacture any parts around the actuator. So our actuators can fit in not just with our accessories, our brackets, but also with whatever you need and whatever you design. Similarly, we have videos at our YouTube channel at youtube.com/HEBI Robotics, where you can find us demoing some of the new tools we have, showing you the latest and best of the cool things that you can do with the HEBI platform. And fourth, but definitely not least, we have the GitHub. So this is a URL that I mentioned earlier. It's also accessible from our documentations website at docs.hebi.us. But this is the center for our example code, as well as for our HRDFs and a variety of other things that help you get up and running. So definitely check all four of these documentation parts out. When it comes to getting support, we want to keep support at your fingertips. So to do so, we have the HEBI community forum at, you guessed it, forums.hebi.us. This is the home base of our support because it provides users a place where they can get support, but also share ideas and collaborate with fellow HEBI users. And it allows our engineers to regularly monitor, post answers, and see what is the next thing that we can do to the platform. How can we continue improving and evolving the platform that we have? It is also, however, a platform for you to share your successes. So if you were able to get something new running, if you were able to get a cool new integration going, come share it on the HEBI platform. You'll never know who this helps other than just your use case. And so when we talk about accelerating the future of robotics, we talk about that collaboration around the world. You might have an engineer sitting literally across the world who can share that work with you as we come together to change the future of robotics. However, when it comes to support, if one-on-one assistance is what is better for you, you can always email us at support@hebirobotics.com, and you can also submit a ticket at our website on our support page. Our website is hebirobotics.com. And really between these three methods, we encourage you to use all of them when appropriate, and we want to make sure that you have the support that you need when you need it. Never hesitate to reach out to us. Putting all this together into a question of the timeline and what it looks like to get started with HEBI Robotics. If you wanted to jumpstart your project with HEBI Robotics today, it takes nothing more than a simple email to info@hebirobotics.com. You can also find prices and quotes on our website at hebirobotics.com. And here is where I want to emphasize that the timeline on the right, which I'm about to go through, isn't the exact same timeline for everyone. It's an average timeline that in many cases we can operate and beat. We can operate faster than. So in this rough timeline, we have initial contact today. We can clarify your needs in 2 weeks, and we can finalize your order and begin production in 3 to 4 weeks. This is actually for custom development. So if you approach us with a need for stock components, we probably already have stock. So that 3 to 4 weeks can become 2 weeks or faster. We also might have pre-configured kits that we sell on our site ready for you way faster than 4 weeks because we don't have to do any custom or further development. We can just assemble that with our stock parts and send that out to you. In this case, we also talk about back to the timeline how in 1 to 2 months we can make sure that development begins on our system. Now, whether that's us developing something for you or whether that's having the robot in your hands for you to do that development, we believe that 1 to 2 months is we can confidently say that we can get you that robot. And again, in many cases, it could be even faster. In 3 to 6 months, this means that your robot system is in action. And finally, beyond 6 months, our support never ends. We're always an email, a forum post, or a support ticket away, if nothing else. So definitely reach out, and definitely if you have any further questions about this timeline, we can answer that at the end of this presentation, or just email us at info@hebirobotics.com to get started with us. We've thrown a huge amount of information to you today. There's only so much time in the world, and we wanted to make sure we give you everything. There will be a recording of this, but I do want to summarize the key takeaways of today. What do we hope to leave you with today? First and foremost, HEBI Robotics creates robotic tools for researchers, academia, and industry. We have a growing set of tools that cater to each of these type of customers, and you might even be a fourth type that we haven't met, but that's okay. Please approach us because we're always open to working with a variety of different groups because our tools are applicable to a variety of different groups. We empower domain experts to make robotic solutions a realistic possibility for them. You do not need to be a robotics expert to use our tools, and that's very important. You could be an expert, for example, in a biology lab, and you want a robotic solution that helps you speed up overnight tests, for example. You don't have to be the robotics expert. We can do that part for you, and we can provide you a solution that allows you to implement that automation easily and more quickly than you could before, and then you can with traditional solutions. You can dream as big as you want because our hardware and software are always evolving. We encourage you to imagine solutions that are not just an arm. I mentioned that we can move faster than traditional solutions. What this means is that traditionally you could have an arm. Well, we can do more than that. You could have a wheeled robot. We can also do more than that. Or you could have a six-legged robot that we showed. We can make it 7. We can add extra joints on those legs. We can do a variety of things to cater to your needs. And so, for example, take the backpack I showed you earlier, the backpack that was created out of our hardware. That's something that's made out of our current hardware, but it's being applied in a new way. On the other hand, we had the inspection solution that I showed you. That was a case where we created new hardware that could complete the application and could be used for the application at hand. So there's nearly no time when we'll say that this is impossible. We will give your thing a consideration and we'll talk about it realistically. Can we make your application happen? And we'll do what we can to make sure it does so. Always remember your 4 best friends in development. You have the example code, you have scope, you have logging, and you have the HEBI community, who is always there for you and always around to make sure that you are developing as fast as you can and using our tools to the best of their ability. And finally, last but definitely not least, we love to hear from you. We are a group of individuals who have a passion for the field of robotics and a passion for what we do at this company. Keep us updated on your progress, whether it's by forum, support ticket, or even just another email. We love to hear from you. If you have a new idea about what to do with the with the hardware that you have, email us. We promise we don't bite, and we're great people who love talking about what we're passionate about. So please reach out, post this webinar, and even in the question section at the end of this webinar. That brings us to the end of our presentation section for today's webinar. But just before we get into the demos, I want to talk about the different ways that you can stay in loop. Make sure you're subscribed to our newsletter. At the bottom of our, at hebirobotics.com, at the bottom of the page, you'll find a simple sign up here that takes your name and email address. That's all it takes to sign up into our newsletter. And our newsletter is the way that we like to keep our users in touch with the latest and best from HEBI. You can find a YouTube video, you can find updates to our documentation, but you will always get a newsletter with an update about what we have for the latest tools. And remember, this is only the beginning of our webinar series. So next week, we have our webinar regarding our new Maps product, and it is on Tuesday from 2 to 3 p.m. Eastern time. And if you want to learn more about that product, you can also check out hebindt.com. With that, I think it's appropriate that we start playing with some robots and get into demo section, for which I will hand it back to Willig, who will get us started with that.
Awesome. Thanks, Hardik. So quickly, I am going to just run down kind of what you're going to see in the fun part of the webinar. So let's all take a deep breath. That was a lot of information, very broad, lots of information. So here comes the fun part. So what we're going to do today is we're going to take you through everything from the small single actuators that I've got here with me today, how you get started, show you some live feedback and commanding with the ability to log also that feedback, show you a quick little series elastic force sensing demo, just show you kind of that force feedback that we can get and commanding the force through these actuators. And then at the system level, we have arms, as you guys saw in the teaser at the beginning of the webinar. I have one here in the office, and Hardik also has an arm at his house. And we're gonna do some examples about showing how the kinematics, you can visualize the kinematics of the arm, do some simple gravity compensation, some collision detection, a simple mobile IO and waypoint teach repeat, and then we'll have some fun at the end and play some tic-tac-toe between the two of us. So with that, I'm going to exit this presentation. And so as you guys can see here, I'm going to stop sharing my webcam too so you can see this. So right now I have an X series actuator you can see here, an R series actuator you can see here, and then I have scope open. So here you can see I have scope open. This on the left column here is where you will see all of your modules, as we like to call them. So whether it's an X series actuator, an R series actuator, a mobile device, an I/O board, anything that's on the network show up in this column. What you can also do is group them. So right here we have Hardik's arm actually VPN'd into the office here. So I can see that his arm is under a family group called control, and each of his modules here have a name. So I can, look at the latency coming across and see the latency and feedback that I'm getting from the modules of his arm. Don't have to dive too deeply into that. But now, like we showed in that video at the beginning of the platform, I can simply, with my power supply off, just to protect from hot plugging any actuators, I can plug in power and Ethernet into this X series actuator. And as I turn power on, you'll actually see both actuators power up because I also have the power plugged in for the R series, but it's not actually, the Ethernet's not connected. So you'll only see this X series pop up. And then I can also show you that this arm I have in the office is also showing up. So you can go in here and you can change the name of this actuator. So I can call this demo actuator. You can get various things of feedback. So right now I'm running at 100 Hertz of feedback. And this is the position feedback. And also show velocity feedback. So I can plot and get this command, this feedback live as all this is happening. So what you can do, you can get feedback from the actuators, but you can also command position, velocity, and effort. So if I bring this up closer to the webcam so you can hopefully see this, and I drag this position, and I click along this slider, you'll see the actuator rotate, and in that plot you can see it commanding to different positions. And in the same vein, I can control the velocity and make it go faster in one direction or the other. If I close those plots. As we said, each of these actuators also have IMUs, so there's accelerometers and gyros. So if I hold this kind of vertically with the y-axis, there's actually markings on the back, so you know which axis is which direction. So you can see here the green line is the y-axis, so that's kind of pointing up right now. I can rotate it 180. Now you see that y-axis is pointing down, and so on and so forth. So there's a wealth of different things you can do here in the monitoring tab of scope. I forgot to mention too, there is this dashboard tab in scope that kind of gives you all your status of whatever actuator you have selected, some more device information, and then kind of MAC address, IP address, connectivity things along that nature. I won't get into these other tabs, but you can set gains. And then we're also constantly doing firmware updates. So if you're working and then maybe a year down the line, you're working with an ARM or something like that, and you open up scope and you refresh and you see a firmware update, that just means we recently updated the firmware because we're always, trying to update our technology and make it great. One day maybe we'll do a webinar focusing just on scope and all these different features, but I'm going to keep moving on. So as I mentioned, these are daisy chainable. So what I'm going to do now is I'm going to plug in this Ethernet cable to the bottom port of this actuator. And the R series actuators are actually, they're still using the 100 megabit Ethernet, but it's actually over fiber. So you can see there's a fiber cable going into this R series actuator. But we have this Ethernet media converter. So I'm converting that Ethernet to fiber, And then as I turn the power back on, you will see both the X series and R series actuators show up. And there it is. So that's the actuator demo. I'm going to set up my little force sensing demo. And while I do that, we can field some questions.
All right, so for those of you that have been asking questions throughout the presentation, if you wanted to see the answers to the questions or any other attendees' questions, you can hit the questions tab in the side menu bar. If you hit the arrow on the right-hand side, it should give you a larger screen that will pop out. A couple of good ones that we have gotten is, can I access actuator firmware to adapt the control architecture to my needs? We do provide multiple different ways for users to customize the control architecture, and you can find more information about that in our docs.hebi.us. And one that just came in from Peter is there an API for scope that allows for non-HEBI actuators to be added in hybrid robotic development? It looks like Scope does not have an API, but we could technically create a bridge to incorporate them. But we would probably suggest emailing us at info@hebirobotics.com if you have a use case, just so we can talk about it a little more in depth.
Colleen, do you want to also run that poll?
I do. I'm going to run a quick poll here that will show up on everyone's screen. You can select everything that applies. So feel free to answer this while Willig gets set up with his demonstration. We'll just wait for a moment here and then we'll get started with the demo.
Yep, I'm ready to go, but
Great.
we can wait for more percentage. Looks like we have about 50% of the votes right now, so we can wait till we get a little bit more.
We also had a question earlier about where we can find the simulator, and that is actually in our GitHub. All right, looks like we are just about 60% on that poll. So I'm going to go ahead and close that in just a moment and hand it back to Willig for his demonstration.
Great, okay. I am ready to go. You guys can see my screen again?
Yep, that looks great.
Great. All right, so now what I have set up here is an actuator with a little link on the end of it. And again, I'm going to turn on the power. And we will see it show up in scope. So here it is, my X89. So what I can do here is if I plot the effort, as we mentioned before, these are series elastic actuators. And I command a 0 position. I can now apply a load to the end of this kind of lever arm, and you can see as I apply more and more load, that effort, basically torque in Newton meters increases and increases, and as I lessen that, it goes back to 0, and I can push the other way, and we can get that effort feedback. So this is really great as a tool. There's also that built-in spring element, so you do get some shock absorbing built into the gear train. Alternatively, getting that effort feedback, you can also command the effort. So what I can do here is go to the effort slider and command a certain amount of effort, and as I resist that effort, you'll see the arm is stopping because I'm resisting that effort. Whereas if I continue to let it go, something else I've done here is I've set a position limit on the actuator, which is something you can do in the gains tab or in your code. So it's actually now position limited as to protect the rest of my setup here. So if I, do a little bit more effort going back the other way and resist it again, it hits that effort threshold because I'm resisting it with my hand. And as I release it, it'll go back. And of course, the gains aren't perfectly tuned with that position. And again, it now hit that limit on the other side. So with that, I'm going to end the actuators part of the demo, and I'm going to play this quick little video as I set up the arm part of the demo. Great. So now I have my arm set up here, and you can see in scope, I have my arm, it's called receive, and I have all of the joints here in scope. So what I'm going to do now is I'm going to run, as we've mentioned a bunch of times, we have a wealth of example code to get you up and running. So one example of that is this kinematics visualization demo. And what this is going to do is it's going to read in an HRDF that Hardik also talked about, that I've pre-written, that talks about, that lays out each of the joints and links in this arm. And it's going to show you the kinematics of this arm. And as I move the arm around, you'll see kind of that kinematics visualized in kind of like a live plot. At the same time, I'll also be logging the end effector of the arm. So when I'm done with the demo, you'll actually see that log and those plots live plotted. So now as I walk over to the arm and I move it around, what you guys should see on my screen over there is you should see basically that graphing mirroring the movement I'm doing with the arm right now. You should see all these black lines and the joint, those coordinate frames matching everything that I'm doing with the arm. So if I kind of do this kind of side to side motion and come back, and I will now exit, and you can see it's now plotting the logged feedback. And now I'm not cheating, it just showed up on my other screen. We can now see that path that that end effector took. And you can see that side to side motion that I took. And with that, I'm going to pass it over to Hardik, who's going to do some further ARM examples and dive into some Python code.
Welcome back to my side of the world. As I mentioned earlier, I'm at home. So I am running some things from this side to show just like I can have an arm at home, just attach it simply with a little bit of 80/20 and get going. So what I'm going to do first is I'm going to show what we call GravComp. The full version, it stands for gravity compensation, which means that the arm will, so to speak, carry its own weight. So when I get this running right now, another fun thing is that, as you saw, Willig was working in MATLAB, but I'm going to use Python instead to kind of show how you can do the same things on the different APIs. And I'll actually, as Willig mentioned, walk you through some code as well. So as you notice now, it is very easy for me to move this arm around, which means that we are actually torque controlling the arm to carry its own weight. So we have from the HRDF file all the different kinematic and dynamic information that we need to be able to know what this arm is made up of, what the hardware is, what's the torque level at each joint. And we can now make it so that I'm not having to put a lot of effort in at all to move this arm around exactly how I want to. This becomes really useful when used as a part of bigger examples, which is what I'll do next. So keep in mind, GravComp is useful, and it's also a really good test, a simple test to see if your arm is running. If GravComp is working, that means you're able to connect to your arm, you're able to command to your hardware, and your network is working correctly. So the next thing I'm going to show you is what it looks like when you have the arm using our ARM API just go to 4 different waypoints. And that's the code that I'll walk you guys through as well. So first up, I'm going to get this running. This will be an example that shows the collision detection aspect of how you can track the torque at each joint if you would like, to know when the arm needs to stop or is about to collide with something that it shouldn't. So I've actually disabled all collision detection for this. So when I get this running, it's just going to go to these 4 waypoints. So as you can see, I have just put in some arbitrary waypoints for now. I'll show you later how you can also train them. And it's just going through them. If I try and come in the way of this right now, the springs in the hardware allow me to be able to push it a little, making it compliant, but it's still not stopping. It's not listening exactly to what I'm saying. So this is where, now that you have just memorize this or keep a mental note of what this looks like. So
hey Hardik, if you have a chance, we aren't seeing the code on our end.
Yes, that's next up. So
great, just checking.
Right now that I've shown you what the demo looks like, I'm going to stop the demo first and then show you what the code looks like. So now it's time to share my screen, which is here. So this is, can you see my screen? I think.
Yep, you're good.
Okay, I've turned off the webcam for now, just so you can see the screen as big as possible. So here what we're seeing is that this is using our ARM API. So this is an abstracted version of what it takes to get going with HEBI hardware. So part of the setup, all it takes to set up an arm in your code is pretty much these 3 pieces of information. So you need to have the family name that you can see on scope, and that makes it easy to find multiple robots on your network. You need to have module names, and you just put them in the order in which from base to end effector. So if this was only 4 joints, you won't have J5 and J6, for example. And then you just have to be able to link to the HRDF that describes the same kinematic information in the HRDF format. From there, you pass these parameters, you collect and pass these parameters to the arm, and then just create an arm object. At this point on, this letter A stands for the arm object that we are going to use to do everything that we're going to do from this point forward. The first thing we do is load gains. So the control gains that define how smooth the motion is. You can set this inside another XML format gains file that can be changed in scope, but also you can just hand change it in a simple text editor and set the numbers that provide you the motion that you want. Next up, we just have some control variables. We don't have to worry about those right now. I have, for this demo, hard-coded 4 waypoints. Now, there's obviously much better ways to do this, much cleaner ways to do this, but I just wanted to show how I can, at this level, even while using the ARM API, set waypoints at a joint level. So I can give exact waypoints to each joint that make up the arm. Similarly, I'm not just giving position waypoints, I'm also giving velocity waypoints. In this case, they're all 0. We just want it to hold at each position. And each motion is going to take 2 seconds. That's all this is saying. So this is, don't have to worry about it too much. There's multiple ways to do it. To set the goal, all I needed to do was update the arm, make sure we're receiving some feedback from the arm, create a new goal using the waypoints, the durations, and the velocities that I just declared, and set goal. That's it. For me to go through those 4 waypoints that you saw, I had to set the goal, and this is all it took to set the goal. And then in my main control loop, all I do is, again, while I have not aborted, I will update the feedback from the arm. Once I reach my destination, I will reset that same goal. And at the end of each loop, I'm just going to make sure those new commands are sent. That's it. So that, like, I have done so, putting out all the spaces and comments aside, I've done so in roughly 35 to 30 lines. Now, what we're going to do here together is that we're going to add a little bit of collision code here. In one of our later webinars, we'll take a deeper dive into the code. But for now, I've just prepared the code, and I'm going to put the collision code into the control loop and just explain what it's doing. So what this is doing is that it's tracking the commanded effort and the feedbacked effort from the base module, which is the 0th module in the chain. So for now, for the collisions, I'm just tracking the base module. I could do so for all the joints if I wanted. From there, I am calculating the absolute error of the difference between what I'm commanding and what I'm seeing as part of the feedback, or what the arm is actually experiencing. If this error ever exceeds this arbitrary threshold of 2.5 Newton meters, then this arm is going to shut down. This is a simple way to make sure that the code, that the arm running in a collaborative environment will shut down before it breaks anything. And so this adds a lot of, as I mentioned, like, it makes it under the flag of collaborative robotics, but it also allows it to do some more sophisticated things when you're picking up objects, when you're navigating different terrains. You might want to trace the side of a wall, for example. This is just showing our force sensing in action. But I hope that code was all visible, because I'm about to stop sharing the code and jump back into showing what this new code looks like in terms of collision detection. So now that I have that new code in, I'm just going to run the same example. And it's going to be doing the same 4 waypoints. So it's just going through the same 4. But this time when I put my hand out and it hits my hand, it didn't work because I didn't actually save my document. That's always save your documents, guys. Now that I've actually saved the changes that we made, we're going to see this in action. Okay, so it's going through the same 4 waypoints. And now when I put my hand out, it stops. So it noticed here that at the base module, it experienced torque more than it should have, and it decided that I'm probably hitting something. It stopped. I'll just run it once again, just to make that clear, and I'll have it stop in a different direction, I suppose. So let's let it cycle through first, and then it stopped. So that's, again, it took about 50 lines to make this happen, to make it do a motion and make it stop when it should not proceed. And that's just to show how easy it can be to control an ARM kit with the ARM API. But obviously we have other kits, we have other tools. This is only the beginning, and this is an piece of example code as well. Finally, and please pardon my network connectivity at home, but I'm going to go so far as to show you what the HEBI teach repeat looks like. So teach repeat is where we teach those waypoints. Rather than hard coding those waypoints, I can have those 4 waypoints ready. So as you can see, I have my, let me make sure this is visible to you guys. I have my HEBI mobile IO app over here with all the sliders, and I'm just going to keep this on as I run this next example. So when it comes to training the ARM, it also is not very difficult with the ARM API at all. We might witness some jitter due to my weaker network here, in which case I'll pass it back to Willig to do the same thing back in the office. But I want to take a dive. I want to see if this demo works at home. For those of you who are working with robotics, you definitely know how demos never go exactly the way you want them to. But okay, so I have the ARM and grab comp mode. I have my mobile IO app running. I'm going to have the ARM start over here. I've added a waypoint. I'm going to have it come look at the camera, and then I'm going to have it come look at me. From there, all I have to do is press a button, and the ARM is running. So I've just taught it 3 waypoints. I've kept it very slow for you, and it's just going to take a look at you guys, and then it's going to come back, and I'm going to give it a quick high five. That's all it takes. That was a little bit of the network connectivity I mentioned, but that's another core example that we have in our example code. It's called HEBI example teach repeat, and it's another thing that you can get going with if you'd like to see how it's quite easy to integrate the mobile IO into your hardware. So that's another fun demo, but now it's time for the big one. So I'm going to have Willig rejoin me, and we are going to do the control receive demo, which is where I use this control arm to control the arm in the office, which is the receive arm. And we're actually going to play tic-tac-toe. So Willig, are you with me?
Yep, I am here, and I am, you got to start, you got to VPN back into the office, please.
Yes. So the way this works is that we are just, I'm VPNing into the office network. That's allowing my arm to be visible to the computer that Willig is running. And that allows him to be able to get the feedback from this arm to control the other arm in the office.
Great, I see it on my end, and I'm going to begin the demo. And I'm going to walk around into the webcam. Hello again, everybody. Let me uncap you here.
So you'll notice how when he uncapped it, I felt that, and that's the feedback I'm getting back from the arm in the office at a torque level.
Can you see that? Is that,
yes,
that board in frame?
Yeah. Keep in mind, if I draw squares instead of circles or any other shape, that's just me. I'm not very good at shapes, you could say, or in other words, you could say that I'm commanding this through a camera over here, so I may not be able to see exactly what's going on. There's also some lag with that, but actually, yeah, we'll just push that arm again, and everyone just notice how my arm is following what he's doing. And I'm going to take that back now. Thank you. From here, I'm going to make the first move. Let's see. Let's go over here. If you have any questions, please be sure to put them in the chat box right now.
Yeah, Colleen, feel free to forward us any questions while we play some tic-tac-toe.
I will do that.
Let's just imagine that's a circle. It's definitely not a cross, is all I'll say. Ooh, bold move, Willig.
Yeah, well, we'll see how that works out.
Abdul asked, is it possible to run the same example code provided on the HEBI simulator? The answer to that is yes. As soon as you start the simulator, the modules will appear and to the APIs in scope as if they were physical modules. So the example code that we have should work without any changes.
As you can see, Willig is now cheating. So he's making my move not where I want it to be. But this is actually to show kind of the compliance of the robot. Even though I'm controlling it, and even though we're controlling the receive arm in position and velocity, there is a certain element of compliance that we allow with our hardware because we have that that torque sensing, and we can do things like that. As you can see, Willig may or may not have used that to his advantage to win. But I'll give you this one. But that's really the big demo we wanted to show you that puts everything we've talked about together. It shows very quickly the different features that we have acting at the same time. So I think this is a good way for us to transition back to questions, and time to hear from our audience if we can. Please put the questions in on the question box, and we'll do our best to answer them.
We just got a question in from Kishore. He said, do you have computer vision enabled on the robotic arms? If not, are there plans for CV enablement?
You want to take that, Hardik?
Yep. As of this moment, we don't have any computer vision on the arms that we use today or in any of our prepared kits, but it is possible to integrate different computer vision toolkits. Most popularly, we've seen it done with ROS, but it's totally possible to integrate it quite easily into using those tools with our kits. So we don't have them off the bat, but we can definitely help you get there because we've done so in the past. On another note, sorry. While we are waiting for other questions, I should add the question was also, are there any plans for CV enablement? Well, what you'll find is that if you'd like to see something from us, you might find it's on our roadmap, or you could help us add it to our roadmap. So if you have any interesting use cases or any projects that you'd like us to hear about, definitely please reach out. And if it's not on our roadmap now, it's something that we can add to our roadmap if needed.
For our European folks who are attending today, Matt asked, are your products CE marked for sale in Europe? And the answer is yes, they are. You folks are welcome to use the chat function as well if you don't want to use the formal question.
But yeah, as other questions come in or as we come to a close, again, just want to thank everybody for their time. You can, like we mentioned earlier, you can head to our website, hebirobotics.com. You could also hebi.us, as Hardik mentioned, along with all of our other links. We can send all that out in our follow-up email. It'll probably come out tomorrow, along with the recording from this webinar. You can also find us on all the social media platforms, so Twitter, Instagram, Facebook, LinkedIn, and our YouTube channel. So feel free to reach out to us and ask us questions if you think of them after the fact, after we finish up here.
All right, we'll just give it another minute, and then I say we're good.
That is the official end of our webinar, though. So please, you're welcome to leave. There will be a recording for this, but otherwise, we're sitting here for questions.
And there will be a survey when you leave, so feel free to give us some feedback through that as well. As this is our first webinar, and we hope there's many more to come.
There is one more next week, Willig. Make sure you all tune in for MAPS. The webinar that is about HEBI's new NDT technology, especially if you know anyone or are involved in industrial inspection. That's definitely something you should check out.
Well, thank you guys so much for joining us. Let us know if you need anything, and have a great afternoon.